Isn't it wild how much more real our digital worlds are becoming? Think about jumping into a game that looks almost indistinguishable from reality or, designing a product in 3D that you can practically feel. That push towards true immersion is creating this huge demand for incredible 3D content. And today, well, we're going to unpack a fascinating new tool that's right at the forefront of this revolution.
That's right. We're taking a deep dive into Step-1X 3D. It's an open source AI framework that really burst onto the scene back in May 2025. Our goal today is to kind of cut through the technical jargon and really get a handle on what makes this so significant in the AI world and, how it might impact everything from your favorite games to the way whole industries design products. We've looked at the technical reports, the project outlines, even some study guides to bring you the most important takeaways.
Exactly. We want to give you the insider's view on why Step-1X 3D is generating so much buzz. We'll explore the core tech powering it, talk about how it could unleash new levels of creativity, maybe transform industries. We'll also consider what this means for us, as users, and take a realistic look at what it can and can't do right now, plus where it's headed. So let's get right to it. What exactly is Step-1X 3D?
Okay, so in essence, Step-1X 3D is a pretty cutting-edge AI system, and crucially, it's open for everyone to use and learn from. It was released by StepSo, also known as StepFun AI, its main job, generating incredibly detailed and, really importantly, controllable 3D objects with realistic textures. You can give it a description like a sleek, futuristic robot, or even feed it an image, and it can spit out a detailed 3D model.
Wow. And it sounds complex.
Well, it's pretty massive under the hood, yeah.
Yeah.
We're talking 4.8 billion parameters that help it understand and create these complex 3D shapes and surfaces. To break that down a bit, about 1.3 billion of those are focused just on shaping the object itself, the geometry. And then a hefty 3.5 billion are dedicated to making it look real, adding all the detailed textures.
4.8 billion parameters.
Yeah.
That sounds immense. How does it actually translate that into a 3D object we can see and, use?
Well, it works in this rather clever two-step process. First, it focuses on creating the basic 3D shape, the structure. It uses a system called a hybrid VAE-DiT. So you can kind of think of it like an AI that can learn the fundamental shapes of objects and then use that knowledge to generate totally new, unique shapes. What's really key here, though, is that this stage produces watertight models.
Watertight, what does that mean in 3D terms? Not like actual water.
No, not quite. Watertight means the digital model is solid and complete. No gaps, no holes. And this is essential because it makes the 3D object actually usable in other software, like game engines or for 3D printing. It's a practical, solid object.
Okay, so it builds a solid foundation first. Makes sense. What about making it visually appealing? That's the texturing part, right?
Precisely. Stage 2 is all about adding those realistic textures. It uses a technology called diffusion-based synthesis, and it's actually built upon SDXL, which you might know is a leading AI for creating incredibly high-quality images. What makes this particularly impressive, I think, is a component they call the texture space synchronization module.
Texture space synchronization. Sounds fancy.
It does, but what it does is ensure that the textures it generates look consistent and realistic from any angle you view the 3D object. So you won't get those weird, blurry, or stretched textures on the parts you don't initially see. And it's not just photorealism either. It can generate a whole range of artistic styles, cartoons, sketch, you name it. It gives creators a lot of flexibility.
That sounds incredibly powerful, very versatile. And you mentioned it's open source. Why is that such a big deal here?
Oh, it's huge. It really is. Step-1X 3D is released under an Apache 2.0 license. That means the actual code, the trained AI models, even the data it learned from, it's all freely available. You can find it on GitHub, Hugging Face. There's even a user-friendly demo online using Gradio, so anyone can try it out without needing a beast of a computer.
So much more accessible than some other tools then.
Exactly. It's a major departure from many other advanced AI tools that are kept proprietary, kind of locked away. The creators at StepFun AI seem to be really aiming to foster open research in 3D generation. And while truly democratize 3D design, making this kind of tech accessible to a much broader community. Developers, researchers, artists, hobbyists.
Okay, so we have a good picture of what Step-1X 3D is. Let's zoom out a bit now. Why is this specific development so noteworthy? In the bigger picture of AI, of technology, what problems is it solving?
Yeah, that's a great question. What's really significant about Step-1X 3D is how it tackles some of the fundamental bottlenecks we've seen in bringing generative AI properly into the 3D world. Historically, one of the biggest hurdles has just been the lack of high-quality 3D data to train these models.
It's harder to get good 3D models than just scraping images or text.
Much harder. Then there have been inherent algorithmic challenges in creating 3D models that are actually usable, not just pretty pictures. And finally, the whole ecosystem of 3D software and tools has been pretty fragmented. Step-1X 3D makes, I think, significant strides on all these fronts.
Okay, let's unpack those, starting with the data scarcity.
Yeah.
How did they get enough good data to train such a massive model?
Well, StepFun AI put a tremendous amount of effort into curating their training data, very meticulously. They apparently started with over 5 million raw 3D assets. And through this really rigorous multi-stage filtering process, they refined that down to about 2 million high-quality standardized examples. This involved things like weeding out low-quality models, ensuring those all-important watertight conversions we talked about, and standardizing how the 3D data was represented. It was a real commitment to quality, not just quantity.
Makes sense. Quality in, quality out. And on the algorithmic side, what makes Step-1X 3D clever?
Well, that specialized two-stage architecture is key, obviously. Designing for geometry first, then texture. But what's also really interesting and potentially very powerful is its compatibility with techniques from the 2D world. Things like LoRa fine-tuning.
LoRa. Remind us what that does.
Sure. Think of LoRa as a way to efficiently teach an AI new styles or specific details without retraining the whole massive model. It's huge in 2D image generation. The fact that you can now apply these established 2D control methods to 3D generation with Step-1X 3D, that opens up a whole new level of control and customization for 3D creation.
Ah, so it's leveraging breakthroughs from 2D AI to push 3D forward.
Precisely. And the primary focus isn't just on making things look stunning, though it can do that. Step-1X 3D is really designed with usability and controllability baked in from the start. The aim seems to be providing a powerful, dependable engine for producing 3D content that you can actually integrate into real workflows.
Okay, so it's tackling these core challenges head on. What does this actually mean for how we create and use 3D stuff in the real world? Where might we see this making a tangible difference?
If we look at the bigger picture, the potential to, well, revolutionize 3D content creation across different industries is immense. Just think about the workflows involved in making 3D assets right now. Step-1X 3D could automate many of the really intricate, time-consuming tasks, potentially slashing production times, cutting costs significantly. Some early estimates suggest it could reduce asset creation time by maybe as much as 50% for certain tasks.
50%, that's huge.
It is. And this also shifts the role of the human creator, doesn't it? More towards high-level artistic direction guiding the AI. AI becomes more like a co-creator, a very powerful assistant. It's probably less about replacing artists entirely and more about giving them incredibly powerful new tools, maybe even leading to new roles like AI trainers or optimizers.
So augmenting human creativity, not just automating it away. I like the sound of that.
Exactly. And the impact isn't just for the pros. Step-1X 3D could genuinely democratize 3D design by making sophisticated 3D creation more accessible, lowering that steep learning curve. It could empower hobbyists, smaller indie studios, even people with basically no deep 3D expertise to bring their ideas to life in 3D. Imagine how much faster rapid prototyping for new product designs could become.
That's really exciting for individual creators.
Yeah.
What about the big industries that lean heavily on 3D? Where do you see it fitting in?
Oh, the applications are incredibly broad. The gaming industry, it could dramatically speed up creating everything: characters, environments, props, effects.
Those assets take ages.
They do. Architecture, streamlining design visualization. Architects could quickly generate and iterate on 3D models. The film industry could see significant cost savings, especially for things like generating realistic textures for digital props and sets. E-commerce is another big one. Think more immersive online shopping, realistic 3D product views, maybe even virtual try-ons. That could really boost customer engagement.
Virtual try-ons using AI-generated 3D models. Interesting.
Definitely. And then there's the metaverse, right? That whole evolving vision of interconnected virtual worlds. It's going to need a constant stream of diverse 3D content. Tools like Step-1X 3D could be absolutely foundational for building it out. We might even see uses in scientific research, robotics, creating realistic simulations, modeling complex structures quickly.
It sounds like the market itself is noticing this potential. Is there growth happening?
Absolutely. The projections are pretty staggering, actually. The AI-powered 3D modeling market, some analysts predict it could grow by something like 300% by 2026. And the broader generative AI market, which includes tools like this, is expected to nearly double by 2030. That's building on the massive growth we've already seen. So yeah, there's clearly a huge appetite for better, faster ways to make 3D content.
Okay, so it's poised to change how pros work, empower individuals. Sounds amazing. But let's get down to brass tacks. Are there limitations? Downsides? What's not working perfectly with Step-1X 3D right now?
That's a crucial question, yeah. It's definitely a significant step forward, but early adopters have run into some technical limitations. One of the most prominent, the hardware requirements. They're pretty demanding. To get really high-quality results, especially generating multiple views of an object, you generally need a graphics card with, say, 24 to 29 gigabytes of VRAM.
Wow, 24 to 29 gigs. So your average high-end gaming PC might still struggle, even with like a 3090 or 4090.
It can, yeah. Those cards often have 24 GB, but users report it can still push them to the limit or require careful setup. It puts it slightly out of reach for many users right now, making it feel a bit GPU Porsche, as some have put it.
Okay, so accessibility is still a bit of a hurdle on the hardware front. But what about the quality of the output itself? Any issues there?
Yes, there have been reports of some quality issues in the generated models. Some common challenges in generative AI still pop up. Things like generating realistic, anatomically correct 3D hands. That's still hard. Users have also mentioned things like fused limbs on characters, sometimes unexpected holes appearing in the geometry, or models that just look a bit thick or blocky.
So it might need some cleanup afterwards.
Often, yes. These imperfections frequently mean you need to do manual post-processing, using other 3D software to fix the mesh, that's called retopologizing, or sometimes using image-to-mesh techniques to refine what the AI produced. It's not always a one-click perfect result yet. Oh, and another thing people have noted is baked-in lighting.
Baked-in lighting?
Yeah, meaning the lighting conditions seem to be part of the texture itself, which can make it harder to place the model into a new 3D scene with different lighting. It limits flexibility.
Right, I see. Any other hiccups? Software side, usability?
Yeah, a few things. Some early users found the initial scripts provided on GitHub for actually running the AI were a bit wonky, was one description. Reports of memory issues, like the software trying to load everything at once and crashing even on powerful GPUs. Users sometimes had to tweak the scripts themselves. And the GitHub repository itself shows a log of other technical issues people have reported. Things like multi-GPU training getting stuck, problems loading data from Hugging Face, questions about the data filtering scripts, issues getting consistency across multiple views of an object, sometimes textures missing in exported FBX files, basic questions about exact VRAM needs or how long generation takes, and even some notes about objects in the training data may be lacking color information.
Okay, so definitely still feels like a technology in its early stages. Some kinks to be worked out?
Precisely. But, and this is important, the future outlook is still very promising. Because it's open source, it's going to keep evolving. The community can contribute, fix bugs, add features. The creators have already mentioned plans for things like comfy UI integration, which would make it much easier to use within existing workflows. And they're actively working on future versions with even more control, letting users guide the AI with multiple images, bounding boxes, maybe even skeleton data for posing characters.
So it's part of a bigger trend.
Absolutely. Step-1X 3D sits within this exciting wave of open source 3D generative AI. You've got other projects too, like Hunyuan 2.0, 2.5, A3D, StableFast 3D, all pushing forward on quality, speed, accessibility. It's this collective effort, and I think it highlights this growing understanding that the best way forward is probably this blend, this collaboration between human expertise and AI power, leading to those new roles we mentioned, maybe AI trainers, optimizers.
Before we wrap up, we should probably touch on the ethical side of things. With tech this powerful, there are always considerations, right?
Oh, absolutely. That's critical. That's another valid point. Training and running these large models requires significant computational resources, which has an environmental footprint. So there's a real need for clear labeling of AI-generated content, establishing accountability frameworks, and just generally thinking through the societal implications. Honestly, the tech is often moving faster than our ethical and legal frameworks can keep up. That's a challenge.
It's a lot to consider. This has been a really fascinating exploration into Step-1X 3D. It's clear this technology holds immense potential, doesn't it? Reshaping how we interact with and create in 3D.
It certainly does. And yeah, while there are current limitations, those hurdles we discussed,
Yeah.
the open source nature and the active community around it give it a strong foundation for progress, for refinement.
Absolutely, and it really leaves you thinking, doesn't it? How will this increased accessibility, getting high-quality 3D creation tools into more hands? How will that transform our digital interactions, our creative work? What new skills, what ethical guidelines will we need to navigate this evolving landscape?
Definitely something to keep pondering as this technology develops further. It's moving fast.
Well, thanks for joining us for this deep dive into Step-1X 3D here on the Before AGI podcast.
My pleasure. Good discussion.
If you found this exploration insightful and you want to stay ahead of the curve on the latest AI developments, definitely make sure you subscribe to the Before AGI podcast for more in-depth analyses like this one. And hey, for those of you who want to dive even deeper maybe into the more practical side of AI, be sure to check out my YouTube channel. It's Ian Ochieng AI. That's Ochieng AI. I share tutorials and further insights into all things AI over there. Until our next deep dive.